We, as part of the project, we want to transfer our knowledge and skills to the PEA staff and build a 10-year vision that can begin to implement internally, which will in turn modernize the PEA grid. Next slide. Okay, so the overall vision is to provide an industry architecture that helps utilities and their vendors implement enterprise-wide electric grid model management practices. So as Dr. Shumpal has been discussing grid models, go ahead, next slide. Okay, the project drivers are the fact that distributed energy resources are growing very rapidly. Customers have very high expectations for grid reliability, and the network analysis on the distribution grid is becoming increasingly popular and needed due to the distributed energy resources and increased dynamic nature of the distribution system as well as the transmission system. So applications need improved accuracy in grid model data. Next. Historically, typical system interfaces are built point to point on an as-needed basis. They don't scale cost effectively. And with the industry changes, not only in distributed energy resources, but on the transmission system, we need as an industry to take a step back and develop a holistic architecture, functional architecture, as well as IT architecture to handle the challenges that are coming our way. Go ahead. So Dr. Shumpal has talked quite a bit about the SIM and SIM modeling. So what is a grid model? In its simplest form, a grid model is a representation of the physical electric grid, or it's a connectivity model. This includes all the pieces and parts that make up an electric transmission system and distribution system, such as circuit breakers, jumpers, risers, conductors, etc. Instrumental in grid model representation is the accurate representation of all the equipment and the electrical parameters. This is one of the things that makes grid model unique to the electric utility industry is not only the connectivity model, but also all the information that goes into that. The impedances, your thermal ratings, your generation curves, how they respond are all increasingly important. Also critical is the connectivity, how equipment terminals are connected. And Dr. Shumpal has gone through the SIM model to show how that is accomplished. The grid model should include a single representation of the current state of the grid. Many times that's called the as-built model. So that is the current state of, in PEA's case, the distribution system as you would find it in the field. Then, to maintain that as-built model, a continuous history of changes to the grid is needed. So anything that would change not only the grid connectivity, but the parameters of the grid, say a new piece of conductor that has different thermal ratings or parameters or impedances, a different circuit breaker, a new bus, a new feeder, these are all changes to the grid that would need to be included, and these can be handled as projects, work packages within the utility that get validated and then included in the as-built model just prior to energization. So we believe there are many project benefits, lots of new capabilities. So a standards-based data model built using the Common Information Model, or SIM, the authority of the grid model data, that is its accuracy, and enhanced grid model management within your functional business practices. It also allows for very sophisticated model scenario creation as the distribution grid and transmission grids get increasingly complex and flows become more dynamic. This will lead to optimized performance, a reduced labor. Most utilities, when it comes to model management, there are groups of people within various business units in the utility that spend a lot of time maintaining an accurate representation of their model. Having a very robust functional architecture that automates as much of this as possible, allows your engineering staff to perform more meaningful engineering work rather than making sure models are accurate. This also improves data quality. Since there's only one as-built model, you eventually solve the problem of having multiple systems with duplicate data, and most of the time the data does not agree. This will, of course, derive more accurate analysis results for faster and more effective studies, and improved operational efficiencies and streamlined technologies. So again, the benefits to PEA specifically are reduced internal costs, labor costs to staff spending a lot of time maintaining their, validating the data in their models, improved reliability of the grid, allowing your staff to practice their engineering disciplines and not data management, increased customer satisfaction as they have a way to connect distributed energy resources, electric vehicle charging stations, AMI meters, and also improves safety and enables the transition to the grid of the future. Yeah, real briefly, the core task of this project, the first was a project kickoff. So we met with PEA. We onboarded several contractors, Dr. Shumpal with Digital SIAM, onboarded several U.S. contractors. So Scott Coe, who's speaking next, is a noted industry expert, and then onboarded PEA with the project kickoff. We then spent a lot of time developing a functional architecture and finalized the grid model data management architecture envisioned and refined that for PEA. We had many calls with PEA staff to communicate and deliver a report on this functional architecture. And then finally, documented the organization and our understanding of the data systems involved. We developed a data domain scope and captured grid model data flows, then documented and delivered report results on that. Next slide. Next, and we are wrapping up this particular effort, is the vision development. We spent a lot of time with PEA staff building use cases, understanding their functional business model, how they perform their task, GIS models, etc. Compare with case studies at other utilities, and then formulate a 10-year SIM-based vision for data management at PEA, as well as identified benefits and risk. Next will be our sequencing tasks, defining and implementation steps, documenting the business objectives, major activities that PEA would undertake, and its organizational impact. Deliver estimates on what PEA would expect to save and to spend internally, and deliver those results. And then finally, the implementation plan, which would be very specific for PEA and would be detailed for year one of a 10-year plan and outline years 2 and beyond. EPRI would also assist with any planning tools and project methodologies. So I thank you very much. I'm very excited that this forum is taking place and hope that everyone derives a lot of benefit from it. Thank you very much.